Hello everybody, I hope you all are doing great. So in this video, we'll look into what is mutual transport layer security. So before we deep dive into the technical part of it, let's take a real life example. So I hope everyone have experienced booking a ride on an Uber or Rapido, right? So what do we usually do here? So we open the app and we enter our destination and a ride get booked. So once the ride get booked, what we'll do, we'll check for the driver's rating and the car which he is bringing, right? So once we are satisfied with that, then we just sit inside the car, and when we are inside the car, the driver will ask us for an OTP, right? So what did we experience here? First we verified the driver and the car. Now in return, the driver has verified us through an OTP. So basically here and mutual trust is getting established, right? So once this mutual trust has been established, then only the ride takes place. If anyone were not satisfied, for example, we were not satisfied with the driver rating, then we would have cancelled the ride. Otherwise, if the OTP was wrong, then the driver would have cancelled the ride, right? So here first the mutual trust will be established, and then the ride begins, or the whatever the negotiation begins. So this is exactly what happens in a service to service communication. So when we have a backend services and especially when a microservice or a service is trying to communicate with another service which is outside of some organization, right? Or within the same organization also, when the service to service communication happens, there must be some validation, or there must be some trust should be established before the communication happens, right? So this is highly seen where there is no trust scenario. Okay, so next I will just show you, or I will discuss one example of service to service validation. Let's say you need a loan, okay, and to apply to for a loan, you went to your bank's website, and on that bank's website, the bank will ask couple of details like the loan amount and the other details. So you provided those details and you send the request. Now technically what happens? Your request will be received by a bank's backend server. So let's say this is the loan microservice of your bank. It has got your request. Now there are a couple of checks the bank has to do before the loan gets approved, right? So one of the check is the CIBIL score check. I hope everybody knows about this, right? So now what does your bank needs to do is it needs to send some data to the CIBIL score server to get the approval, or to get your CIBIL score, so that it can approve the loan, right? But now, as you know, the CIBIL score is an external agency. Okay, so now here the CIBIL score server will be in some external network. It's in CIBIL scores VPC. Now what do we mean by VPC? So VPC is nothing but a virtual boundary which is created. Inside that boundary, all the servers of a particular organization will be present, right? So let's say it's like an institutional boundary. So inside that boundary, all the different blocks of the institution will be present, right? And to that institution, there will be only one exit and one entry point, right? So exactly like that, we have a concept of VPC. Here within that VPC, all the relevant servers of that organization will be present. So now within the bank's VPC, the bank's microservice is present, and within the CIBIL score agencies VPC, CIBIL score microservice is present. So for time being, you can just ignore this VPC and network. That's not the thing that needs to be concerned here. So just understand that we have two microservices, but both belongs to different network. Okay. So now this microservice needs to send a request to this microservice to get the CIBIL score details, right? But as we said, these two belongs to different organizations. Now comes the trust issue, right? So now how does this microservice should trust this so that the data exchange should happen? If this microservice was present within their VPC, within their known server, then there would not have been any issue. They could have just directly communicated and get the data. But now this microservice is something external, where both needs to be trusted. So now how this trust is established, that is where mTLS, or the mutual transport layer security, comes in. So let's understand that technically how that happens. Okay. So for this to happen, first entity here we need is a certificate authority. Okay, so now what is a certificate authority? So to understand this, let's take an example of a currency. Okay, so let's say you want to buy something, and you, let's say you want to buy some fruits. You went to a fruit seller, you bought 1 kg of fruit, and then you hand over a piece of paper, right? A piece of paper you hand over, and in return you get you get the fruits, right? So what is happening here? Just for that piece of paper you are getting some goods. So here somebody is there, or some, we have set a mechanism where that piece of paper had some value, right? And who is setting that value? There is a central authority. In India we have RBI, right? So here this CA or certificate authority is like an RBI, which is giving an authority to some certificates. So that certificate here acting as a currency. Okay, so in the similar sense, just understand here we'll set up a server, or we have many certificate, well-known certificate providers like GoDaddy. Then we have Let's Encrypt. Okay, so these are the some of the famous certificate authority. So now what do we do with the certificate authority? Like what do we configure, or how do we use these providers? So we go to, let's say we go to GoDaddy. Now what we do? So there first we will generate a private key. So what is a private key here? Private key is nothing but a random bits of number. The larger the private key or the bits of number, the higher will be the security, like it will be difficult to identify. So here first we create a private key. Now with the help of that private key we create a public certificate. So here CS stands for certificate authority. Now this public certificate will form the root of this whole authentication process. So what do I mean by that is, once we have this certificate CA dot certificate, we just take that and add it in all our servers wherever we need to establish a communication. So for example, here in this case we need to establish a communication between this MS1 and MS2, that is, this is loan and this is the CIBIL score. So though these are different organization server, so once, let's say we have one bank A wants to do a deal or make a partnership with CIBIL score agency. So when they do that partnership, at that time they needs to exchange these keys. What do I mean by that? For example, let's say this certificate authority is used by this microservice. Now let's say and this is another one. Let's take this. Okay, so this is GoDaddy and this is Let's Encrypt. Let me just copy. Okay, so let's say this is Let's Encrypt. Now in this case, when we have different certificate authorities, what we need to do, when the certificates are generated, we need to pass the certificates to each other. So let's say if this is using GoDaddy, then this GoDaddy certificate must be present over here, ca.crt from GoDaddy. Okay, similarly, now this is IC, let's say this is bank A. So here it has to be ca.crt from Let's Encrypt. Okay, so this is the first step. So usually there can be a chance where both the organizations are using same certificate, same CA providers, or there can be different. Okay, so let's take a scenario where they are using different. So now this one we have here and this one we have here. So this is the first step which we need to do when we want to establish mTLS. Okay. Now next step is which we need to do in each of the server. So let's take example of one server, and that is the same thing we need to do in another one. Okay. So here the first thing which we need to do is we need to generate a client.key. So this is exactly like ca.key. What we did here, we need to do the same. Again, this is a random number which we need to generate. And this needs to be kept very secret, either in a vault store or somewhere which cannot be exposed to the outside world. Nobody should be having access to this. It should be kept secret. Okay. So once you have generated this, Using that key or client.key, you need to generate another file that is client.csr. What does CSR stands for here? CSR is certificate signing request. As within the name it suggests, it is a kind of file that needs a signature. So basically what we are doing, with the help of the client key along with some other required data, we are generating a file known as client.csr. Now this file is ready to be get signed by this certificate authority. So now this microservice will not make a request to the certificate authority because this microservice is already having this ca.certificate. Okay. So here, I just said we have exchanged this. So this exchange happens when the deal is done between two entities. But before that, this should have its own certificate also. So this will be having its own certificate, ca.crt from GoDaddy. Okay, let me just realign it. So exactly same thing. It will also have its own. So now what is the purpose of that? So with the help of GoDaddy's certificate, it will sign this .csr file and then it will finally get the client.certificate. Okay. So now finally the final file which we need is the client.certificate. Okay. Now exactly same thing happens over here, and here we will have a final file that is server.certificate. I hope till here it is clear what are the different files we have generated and what is the purpose of that. Let me just quickly repeat. Client.key is a random number that we generate and that is kept secret. Using that client.key, we generate client.csr, that is a file which needs a signature. So that is generated and kept, and over that we apply our CA authority certificate and sign that, and post signing that we get a final file that is client.crt certificate. So all these steps which I am discussing, I'll just practically show you everything. Okay, so don't worry about that. Okay, so now we have these two files. Now let's understand how does the request happens, how does the encryption happens. So here, when this microservice wants to communicate to this, what it will do, it will first make a request, and when it makes a request, it will ask for a certificate. Okay, so when it asks for a certificate, what it will do, it will pass this client.certificate to this server. Now you may get question, now how will this validate this? So as I discussed earlier, before the contract happens, they will exchange the keys. Now this server will already have the ca.certificate of GoDaddy already with it. So now what it will do, because this was signed using the same certificate, right? So now what it will do, using this ca.certificate, it will decrypt it and it will make the validation. So now what happens, for the server 2, the server 1 is validated. Okay, now server 1 will say, hey, you have validated me, now I want to validate you back. Okay, so now what we'll do, this server will send its server.certificate to the microservice 1. So now how will this validate? It will also have the let's encrypt ca.certificate because it was exchanged initially. Now using this, it will decrypt this file and it will validate. Now both has been validated from both the ends. So this is what mutual transport layer security, where mutually both the parties have validated themselves using a certificates. Okay, so now the validation happens. Now whatever the communication happens, that will be encrypted. So what are the different packets which will be exchanged, I will discuss next. Okay, so now a question will come, how does this is helping, like from a man in the middle attack? For example, let's say, what do I mean here? So let's say this is a man in the middle, or you can say malicious server, a bad user who wants to hack the system. So now when he wants to hack the system, what he is missing? So now, if by now you may be getting the thing which he is missing are these certificates. Okay, so these certificates are present with only those servers which are already known to each other. So now this server is not known to these people. So now let's try to uh, analyze couple of things. Let's say now this server also what it does do, it will generate a client.key, it will generate a client.csr. Okay, so till these two steps this server can also do, but it cannot do the third step because it doesn't have this certificates. So it may get a certificate from any of these CAs, but it will get a certificate with some different, which is signed with some different keys. Okay, that will not match with these certificates. So this is where the man in the middle attack is prevented. Okay, so now this server will never be able to communicate with any of these servers to exchange the data. Okay, so that is the first thing. Now second thing is, once this channel is established, that is HTTPS SSL has been established, whatever the data which is flown, it will be encrypted. Okay, so though this man in the middle can read the data, can capture the data, but he cannot read it because that will be encrypted. It will be a waste of thing with him, for him, whatever the data he will be reading. Okay, so this is the reason why mTLS is highly used in many organizations or in many backend server where security is the priority. Okay, and you can take any banking applications or any healthcare application, mTLS is used for the service to service communication, and the reason is that it will prevent the man in the middle attack. Okay, so I hope you are able to understand this whole scenario. But still, if you have some doubt, you can comment down in the comment section. I'll just try to reply on that. Okay. Now, next, let's see what exactly packets are transferred between these two, which will help them to establish that secured pipeline. Okay. Step by step, how the communication is established and the secured pipeline is created between the two services. So here I have marked it as a client, but it's like another microservice, microservice 1 and microservice 2. Okay, so how does the communication starts? So here, when this microservice wants to communicate with this, it first sends a simple synchronization message. You can just say in simple words like, hey server, I want to talk to you. So like that, a message will be sent like a synchronization message. So here 1 2 3 stands for the sequence. So first a client sends a synchronization message, okay, to the server. Now the server responds back with a acknowledgement. Okay, so it says that I have received your synchronization message and I am acknowledging that. Like, okay, let's talk. So now once the client got the acknowledgement, then it sends back that acknowledgement that it has received back that acknowledgement from the server. Okay, so these are the first three packets which are sent between the client and server, and this is what we call TCP handshake. Okay, three-way handshake, and we have two-way tear down. So when the connection has to be terminated between these two, client and server, or the microservice 1 and microservice 2, at that time two-way tear down happens, where again the two packets are sent in between to break that connection. Okay, so this is three-way where three packets are sent and received to establish the TCP connection. So once the TCP connection is established, now the TLS handshake happens. So what does TLS here? That is transport layer security. That encryption should needs to be happened. So now this is where next set of packets will be exchanged. So let's first understand what is the first packet it will be they will exchange. That is, the client will send a message that is called as a client hello. So we will see exactly this is a message which will be sent. I will just show you. Here we will not be involved anywhere to configure these things. This will be pre-configured, and this is what the messages we will see in the network when the connection is being established. Okay, so during the TLS handshake, first the client sends a message with the client hello. Along with that, it sends couple of information. What are that? First thing it will send is a supported TLS, the version it is supporting, so that it needs to communicate, right? So either it is using 1.1, 1.2, 1.3. Okay, so let's say it is using 1.3, so it sends 1.3 to the server, and then it sends the cyber suites. So these are nothing but the algorithms and the encryptions it wants to use. Okay, so let's take simple example. Let's say the algorithm it wants to use is ABC, and the encryption it wants to use is XYZ. Okay, so this is the algo which it needs to use, and this is the encryption. Okay, so now these two informations are sent in the cipher suites. Okay, so now next final thing is random number for a key generation. So this is the very important thing which the client sends. So just assume that right now for time being, this is again a kind of a key, a random number. This is like a half number. It's not a complete, it's just client's part of number that it sends. Okay, so these are the three messages which the client will send in the first packet when it sends a client hello. So about the TLS cyber suites which will have algo and encryption, then the random number for key generation. Okay, next at the same time, next what the server will do, server will send a server hello message. We will see this exact message. In the server hello message, it will send again the supported TLS and the cyber suites. In the cyber suites, it will send the accepted algo and encryption. So what do I mean by that? When the client has sent a list of accept, it wants to use the algorithm and encryption. Now the server needs to choose between these two, like which algorithm among the list it want to use and which encryption. So that data it needs to return back in the server hello message. So in the cyber suites, it will be returning back which one we will be using for the communication. Okay, and then it will send up its part of random number. Now at this stage, if you observe, now both the client and server has their part of number. What do I mean? Here first the client generated its part of number. Okay, it kept that with it and it also send it to the server. Now that part of random number, let's say the number is 1 2 3 4 5. So this number is now present with both, right? When it is present with this because it has generated and it has sent over client hello, it has this. Now the same thing what the this will do, server will also generate some number 7 8 9 10. Okay, so let's say now this will be generated over here, so that's why this will be definitely present here. Now when this sends it over server hello, so this will also have that number. Okay, 7 8 9 10. So now both have the complete number. So this number or the key will form the private key over which the data gets encrypted. Okay, and the algorithm and the encryption will be used. That will be that data will be presented in the cyber suites. I hope you are able to get what the first set of communication will make sure. So basically, these two packets which are exchanged, within this the whole system is established, like which algorithm will be used or which what will be the key. Okay, so once that is done, next what it will do, next again the server what it will do, it will send its certificate. So the certificate which we discussed previously, so that certificate will be sent along with one encrypted message. So that can be any message, let's say some message like hello. Okay, so it just sends a hello message with the server certificate. So now what the client will do, it will first validate this certificate. I have already discussed how the validation happens. Then it will try to decrypt this message along with this key. Okay, now it has a whole key, its part and also server's part. So using that key, it will decrypt this hello message and it will try to read. Okay, if the decryption was successful, now what will do, the client will send its certificate and an encrypted message. So then what the client will be sending, it can, let's say some other or other word, let's say world. Okay, so this is the encrypted message which the client is sending. Now the server will validate the client certificate, along with that it will try to decrypt this message. Okay, so if the decryption was successful, now the final pipeline or the connection has been established. So this was the second step, that is TLS handshake. And the third step here is the secure communication. Okay. So the secure communication, in this step, we have already established the encrypted pipeline. Now over that, the data will be sent, and we call that as a secure communication. Now whatever the data which will be sent in between, that will be encrypted, and only these two servers will be able to decrypt that, because only these two have the whole key. Okay. The other servers which may come in between as an attack or a malicious server, those will not be having this key. So first of all, they will not be able to establish the connection. Okay. So then only, like, we can think of the message receiving, but first of all, they will not be able to establish the connection itself, because they will not have the certificate. Okay, so I hope you are able to understand the whole flow here, how the mTLS is established. So here I hope you are able to understand what is mutual transport layer security. Okay. So that's all about the things which we needed to understand. Now let's see practically how to implement this. Okay. To implement this practically, first we need to generate a couple of certificates. So here I have mentioned a couple of commands that we will discuss to generate those certificates, and I'll also discuss what is the purpose of those certificates, which we have already discussed, but I'll just repeat it again. Okay. So the first command here we have is using an OpenSSL. We are trying to generate the uh, private key of the certificate authority. So here, what is OpenSSL? OpenSSL is a toolkit that will be used to generate the certificate. So this is a common toolkit that the many certificate authorities may be using. I'm not sure, like GoDaddy or Let's Encrypt. So what they are internally using, I'm not sure, but uh, they may be using OpenSSL. So it's a general toolkit which you can use to generate the certificate. So here we are not going with any certificate provider. So here we are generating the certificates by ourselves. So I'm using this command to generate the private certificate of the certificate authority. So this command is for to generate private key for certificate authority. Okay. So now using this private key, we will generate the public certificate that will be supplied to the services. Okay. So in the second step, that is what we are doing, to generate public certificate. Okay. So here, if you see, there are a couple of things we are providing, like key is the key which we have generated. So it will be referring to this key. Next we have subject. So subject is to identify this certificate like uniquely. For example, in the subject we can have the country code, the state, the city, or the organization for which we are developing, we are creating the certificate. Okay. So here, instead of adding multiple parameters, I have just added the common name. So I'm generating this certificate for my CA. I've just added a simple name. Next, the expiration date and what is the output file name we want. So that will be ca.crt. So I hope these two are clear. So these two are the first step which we need to implement, where we are establishing the certificate authority. Basically, we are creating a public certificate using the private key. Now this certificate will be used by both the servers to validate their certificates. Okay. Next, the next command here we have is this is to, now this commands or this is which we do inside the microservices. So the first command here is to generate the private key. The same way we have what we did for the certificate authority, here we need to do it for the server. So first, once we have the private key, next we need to generate the CSR file, right? We already discussed what is this CSR file, which further needs to be signed by the certificate authority, so that finally we will get CRT certificate, the final certificate of the server. So now this file, this command is to, I hope you are able to relate these things because we already discussed what is the purpose of each of these file and keys, okay, to generate the .csr file. So this is nothing but certificate signing request. So now we have generated such a file which needs to be get signed. So that we are doing in the next step. So in this step, what we are doing to generate a final certificate using the .csr file, okay, which we have generated. So here how this is created. So now this file will be signed with the help of this .ca.crt, which will be present over here, okay. So here if you see the certificate authority we are mentioning, and ca.key we are mentioning which key it needs to be. So all the parameters which it needs we are adding it here, and here we have one more parameter, that is ca certificate serial number. So here every certificate should have a unique serial number for the server, okay, so that different servers will have different certificates with different serial numbers. So these are nothing but you can say different identifications which we need to add here, okay. So now what did we do here in the server? First we generated the private key, then using that private key we generated a .csr file. Using that .csr file we generated a final .crt file, server.crt. Now this server.crt we will be using to send it to another server for its validation, okay. Now exactly same thing I am repeating over here, these three for the another server, but I am just changing the name as client.crt, but the procedure and the purpose is same. So I'm just skipping this part, okay. So the next command here we have is to generate a file in a key store format. What do you mean by that? Let's understand that. So till now what we did in both the servers, let's take example of one server. In each server we created these three files: server dot certificate, and with the help of server dot key, and then we have ca dot certificate which we got from the certificate authority. So we have these three files in the each server. But our Java or the Spring Boot application does not understand, or it will not read these three files, okay. So it wants one single file having all these three information, okay. So due to that we need to convert or bundle these three files into one single format file that is known as pkcs12. So what does this pkcs12 is? It's nothing but public key cryptography standard, okay, standards, and we have the version as 12. So this 12 stands for it's a 12th version of this file, like it started from hash 1 2 3 4 and now it is 12th version, okay. So what does this file format is? This is a key store file format that Java understands. Now why the Java uses key store? Because key store is first password protected, okay. So we can put a password on the key store, so it's only the system having the password can access this key store and the files inside it. Then it's encrypted, it gives us storage with encryption, okay. And the third important thing is tamper detection. So if there is some tampering happen, then that will be detected. So these are the couple of features or the advantages which why we need to go with keystore. And this also compatible with Java and Spring Boot applications, which will be easily able to read the files from keystore, okay. So these passwords and everything we will be providing while doing the configuration. I will show you that. So before that, here this is a command that we will use to generate this pkcs file that will have all the three files bundled inside it, okay. And then finally we will get server.p12 file which we will use for doing all the operations which we have discussed. Okay. And here if you observe, we are also setting the username and password for this file to be accessible. Okay. And now one final file we need to create. Let me just show you why and what that is. That is again a ca.p12 file, which is nothing but a conversion of ca.certificate. Why we need this file? Because when our server gets a request with some certificate, that certificate needs to be validated, and we do that validation with the help of ca.certificate, right, which we got it from the certificate authority. But here, as I discussed, Java or Spring Boot application do not understand its CRT files, so we need to convert them into ca.p12 file. So finally, in our Java applications, we will be having these two files, that is ca dot it is server.p12 and ca.p12. The other server or the client will have client.p12 and ca.p12. That will be common across both the servers. Okay. So let me just rearrange them properly. Okay. So these are the commands. I'll just posting these by formatting them correctly into a GitHub repo, and I'll share that repo in the description link. You can check that out. Okay. So these are the commands and the certificates which we need to generate and we need to use. I hope you are able to understand all the commands and all the certificates. So when we look it from externally, like it seems to be very big, but when we try to understand this, these all are simple things which we need to implement. Okay. So now let's run these commands and let's see the implementation practically. Okay. So let's move to one of the server and then we will run all these commands to generate the required certificates. So now here I am on the client side. So what do I mean here? It will be a server that will be acting as a client. Like it will be sending a request to another server. Okay. So this is basically a server which will be acting as a client. So to generate these commands, like to generate the certificates, we will generate them into a separate directory or a folder, and from there we will move them to the required places. Okay. So right now I am inside this application. So let me just go back one step back. Now I am here, and here I have these two servers, mTLS client and mTLS server. So here let's create a directory called certs, certificates, where we'll store our certificates. So let me move inside this. Okay, now I am inside the certificates. So here let's start to run all these commands. So if you are on MacBook, then you will have the OpenSSL pre-installed as a key tool, which will help you to generate certificates. Please check for the Windows, like how you can configure. You can just refer to some article or the video on or the YouTube. You will get to understand this. Okay. So now coming back, I will first run this command, which will generate the private key. Okay. So here I have my private key of the certificate authority. Next, I will generate a public key of the certificate authority. Okay, so I have the public key and the private key. Now, what next? We need to generate a private key for the server, one of the server. So we will do everything over here. We'll later on transfer the required files at the required places. So now I have a server.key, the private key. Okay. Next what I need a .csr file, which will be now I will sign this file with the help of ca.certificate, and then finally I will get server.certificate. Okay, let's sign that. Okay, so now what I have, server.certificate. So this is final file which my server needs. Okay, so let's now this we are done for the first server. Now let's do it for the another server also. So here for that also I need to first generate the key, then CSR, then the certificate. So let me just quickly run this. One, this is second, and this is third. Okay. So now if you look at here, you will have client.certificate and server.certificate. So these are the two files that we need for the client and server. Now, as we discussed, these are the still .cat files which the Java or the Spring Boot application will not understand. So for that, we need to convert them into pkcs12 file, right? So now to do that, let's run this command, which will generate those. Now this is for the, so here if you have see server.p12 file, we have got it for the first server. Now let's do it the same for the second server, that is for the client. Okay, now we have server.p12 and client.p12. That's it. Now one final file we need, that is the certificate itself, public certificate itself in the form of p12, that is key store. Okay, let's see, we have right ca.p12, client.p12, server.p12. Okay, so now these are the three files, that is this file will be common for both the client and server. This will be for client and this will be for server. Let's move them. So to move them, I will just use this command. So this will move the server.p12 to the resource folder of the server. Okay, so I'll just show you, we have server over here. If I go to src main resource, okay, so we have here server.p12. Now similarly, we need to move the next file, that is ca.p12 over the same place. Okay, so let's do that. Now let's check. Okay, so we have ca.p12 as well. The same thing we need to do for the client as well. Okay, and also copy the ca.c12. Right, so let's check. Okay, so we have these files, right? Now we are done with the certificate creation and their transfer at the required location. Now let's quickly see the configuration part of both the servers, and we will see how practically mTLS is established. I will show you what are the network packets that are transferred using Wireshark tool. That tool we'll use to look at the network traffic. Over that we will understand how the mTLS is established between these two. And if we try to do some break, or if we try to break something, then we'll see how it will reject the request. Okay, let's start with the dependencies that we have added. Let's check that first. So here I have basically added three dependencies. The first one is a Spring Starter Web that is needed to create the REST APIs and the Tomcat container. Then we have two dependencies related to the HTTP to establish the TCP connection along with SSL. So these two dependencies will help us to enable that or to implement that. Okay. So post adding these dependencies, then there is just one simple thing that I have done here, that is created one simple REST template which I'll using to call the another microservice. Okay, so in this REST template, if you look at the code, it's very simple, where we are just loading the required data into our bean object, into our REST template. That will help us to establish the proper connection, right? So here first I'm just telling the file type. We are using the key store type with pkcs12. Earlier they used to use the JKS format, which is now deprecated, and now they are using pkcs12. So then here I'm passing the file name. When we do that, this will automatically pick the file from the resources folder. This file we already have. Then the same, we have these two. So the difference is the first one is a key store, the key store file, and the second one is a trust store. Trust store means the certificate, CA certificate, which you got from the CA certificate authority, and this is the client certificate. Okay, so these two things we need to load. Once we do that, we need to set the SSL context. Okay, so to set the SSL context, again we need to load the key material and the trust material, which we have created here. We will just pass it over here and create a SSL context. So SSL stands for secure socket layer. Okay, so this is again another name for TCL. Either you can call it as SSL or TCL. The meaning is same. Next, we have the pooling HTTP client connection manager. So basically here we are creating a connection manager that we will pass over into the HTTP client. Okay, so here in the connection manager, we are passing this SSL context to create that connection manager, and then that connection manager we are passing into the HTTP client, and finally we are creating an instance of HTTP component client HTTP request factory. So this factory we need to pass into REST template, so that once we call this using this REST template, when we call the required services, that will be SSL enabled call. Okay, so basically you are creating a SSL enabled communication with the another microservice. Okay, so now where I am using this REST template, I am using it over here. So here I am using the command line interface that will be automatically triggered, like when we have added add bean method. So whenever the Spring context looks at this bean, it will automatically trigger the run method, and here we are making a call to the another microservice that is running on HTTPS. Okay, just mention focus on this. This is HTTPS, that is SSL enabled. It's not only HTTP, and it is running over 8443, and the API we are calling is secure. So this is the API we are calling, and we are expecting some response, a string response. So REST template.get for object, and finally we are just printing that response. Okay, so I hope you are able to understand. Very simple configuration I have did. Created the REST template and then calling another microservice. Now let's go to the server. So in the server, the first thing in the pom.xml, that is dependencies, here I have just added the web dependency that will enable the Tomcat container, and we can able to create the REST template, right? REST APIs. Now here the first thing we need to look at here is the application.yaml file. So in this application.yaml, I have defined a couple of things. The first one is port. This can be changed to some other port as well. Next, the SSL configuration. So what do we mean here is, whatever the APIs that will be called on the server, they must be called over the SSL. Okay, so SSL is enabled. You need to call over HTTPS. That is what whenever the connection TCP connection get established. Okay, where did we go? Yeah. So once this TCP connection is established, next TLS handshake must happen. Okay, so if TLS handshake doesn't happen, then the SSL the TCP connection gets terminated. So this we have enabled over here. When we do SSL enabled, automatically this second steps comes into picture. Okay, so what we are doing here, enabled is true, then key store location we are saying that within the, when we define a class path, that means it will automatically look into the resource folder. So here it will find the server.p12 file, then the password, if you remember, we have set this same password when we are creating this file, then the key type store, then the trust store, that is ca.p12 password and the type, and the final thing is client authentication. So what does this mean? Once the server is authenticated by the client, okay, once the client sends the request, server does it authenticates itself, hey, I am a genuine server. Now what the server will say, if we have not added, then if we have added, then what happens? The server will also ask the client to get validated. Okay, so now the client also needs to get validated. Only then the packets or the data will get transferred. If client does not get validated, then the communication gets terminated. So that is enabled with the help of client authentication is needed. Okay, so these are the configuration we need to add in the server side. I hope you were able to get both the sides communication, okay, client side and also server side. That's it. And here we have just one API, simple API, which we are calling from there, and it is going to return the hello mTLS client. Okay. I hope you are able to understand both the configuration. The configurations are very simple. Now let's run this application. So let's first run the server and then I will run the client. So let's run this. Okay, so our client application is up and running with on 8443. Now, one thing here I want to highlight, the next thing, that is a tool which we'll be using to monitor the network. What do I mean here is, once a client sends a request to the server. So both the client and server are different entities. They are located at different places, but they are communicating. So when they are communicating, they will be transferring some data or the packets between them over some channel. Okay. So to locate those packets, to see what the packets they are sending, what is the encryption they are using. So all these information can be tracked using a tool called as Wireshark. Okay, I will be showing you what is that tool. So you can just go to Google and just download the Wireshark and install on your machine. And then post installation, what you need to do, I will just show you. Okay, installation is very simple. You can just go to the Wireshark website and just download the required files. If you are on Mac or if you are on Windows, according to that, you can just do the installation. Okay. So here, now let me just show you. Server is running. I will not run the client now. Just I will give a walkthrough of Wireshark. So I have started the Wireshark here. So if you see now, I am connected to the Wi-Fi network, and if you observe here, this is the Wi-Fi network traffic which it is monitoring. If I open this, you will see these are all the application data right now going and coming between my system and the outside world. Okay, so this is continuously, whenever the Wi-Fi is on, all these data is coming and going. So if you see, most of them are TLS enabled, and couple of them can be only HTTP without TLS. So this is for the computer, like the your server, your machine and outside world. So though that traffic you can monitor over here. Okay, let's say you go to YouTube and you start watching a video, or you go to any website. What you are doing, you are trying to communicate with outside world. So that communication you can verify or monitor from this place. Okay, so why it is not recommended to like add the credentials in an open network, or a network where HTTPS is not enabled. This is the reason. Okay, so anyone on that network can just do monitoring of all the packets which they are sending. So let's say you went to a library or any public place and you connect to their Wi-Fi network. So now whatever the data which is going from and in and from your machine, they can track all that data. And let's say, let me just track one of the data. So I just selected this. Okay, so when I select here, I will get all the required data which is going through this. So now if you see, this is TCP, this is TLS. So whatever application data you are seeing, this is the actual data which is getting passed. But here if you see, this is a TLS 1.2 enabled. So that means whatever the data which will be passing now, that will be encrypted. I cannot be able to read that data. So it is none of my use. So that's the reason it is always recommended to use a private network and also go with the HTTPS, not the only HTTP. Now let's come back to what we need to do. So here we will not be able to monitor the traffic which is happening within my server, because both these applications are present within my system. So now this traffic I cannot monitor over here. I need to monitor it from somewhere else. Let me just show you that. Okay, so for that, let me first stop this. Then let me go back. So here, to monitor the internal traffic, we need to select this loopback LO0. So let me start this. And here if you see, okay, so now I have entered some filter. So here if you see the TCP port 8440 443. So what I'm saying or doing here is I want to monitor only traffic which is coming or going from this port. Okay, so right now there is nothing, so I have just added it, and now the Wireshark is running. So now let me start the application. So let me first start the server. Okay, so server has started. Right now there is no traffic because it has just started. Now you will see the traffic once we start the client, and it will try to send this request. Okay, let me start it. Okay, so if you see, we have got the response successfully. So now let's go back here. Okay, so if you see here, all these are the packets or the data which has been transferred or communicated between these two, client and server. So this is where the man in the middle, man in the middle attack or any kind of attack can happen, where the people can monitor your network and they will get that whatever the data you are passing, if that is not over a secured channel. Okay, so now let's understand what are these data. Here what we had is the first TCP handshake, right? So in this TCP handshake there were three packets that were communicated, right? First the synchronization acknowledgement, then the acknowledgement from the client. So you can see these are the three packets that are being communicated. First from the client. So this is the port that the client got, and it is sending the data over 8443, that is synchronization message. This is the first one. Next, it is receiving back the acknowledgement, that is synchronization plus acknowledgement that it is receiving. So if you observe here, we have not done any configuration. This is all happening over the TCP protocol. So this is a protocol that will automatically take place. So now finally the client is acknowledging back to the server. So with these three steps, the TCP connection has been established. But now what we have did in the application is that the server wants the communication to happen over SSL. So due to that, now what will happen? It will try to do the second step, TLS handshake. So that is the reason now we will see these messages in the packets. So let's see. Now we have this client hello. So this is a client hello message that is sent by the server to the client. Okay, and in that, what all the things they get transferred, they will transfer the supported TLS, cipher speeds, and random number for the key generation, right? Same thing happens from the server side also. Server hello, they will transfer all the same things, and once these two steps are done, then these two steps will be done, that is passing the certificate and a single encrypted message to validate. So that is happening over there with the application data. So this application data, one over here and one over here, first it is from the client to the server, and then from the server to the client. So at this point, the TLS communication has been established. So now from this point onwards, whatever the data is been transferred, that will be automatically encrypted. And how they are able to decrypt it? Over the keys which they have already. So I hope you are able to understand this whole phenomena, how the server to server communication happens, and how do you make sure that they happen over a secured channel. Okay. So yeah, so that was it which I wanted to show, and which I wanted to show how to establish the mutual transport layer security. Okay. Yeah, so that's it. So all these resources you will get in a GitHub repo. So I will share the repository link in the description. You can just watch it, or you can just download those data, like the code, and you can run it in your local to do a small POC like this. Okay. Thank you, everyone.